Every 3 months, the speed of artificial intelligence computation doubles. The AI revolution is on, and people have never been more scared, excited, and curious. How good is it? Will it replace us? Is it better than our brain? In this video, we'll explore how the brain and AI stack up in 8 categories. Let's get started. The categories are vision, creativity, memory, motor skills, learning, decision-making, communication, and energy efficiency. Starting with vision. The human brain processes visual information through a complex network of neurons and synapses. When light enters the eye, it is converted into electrical signals that are sent to the brain. The brain then processes these signals to create a visual representation of the world around us. This process involves analyzing patterns of light and color, recognizing shapes and objects, and interpreting depth and distance. On the other hand, AI systems like Dall-e and Midjourney use algorithms to recognize and classify objects based on visual cues. These algorithms can be trained on massive data sets of images and use machine learning techniques to improve their accuracy over time. For example, a neural network may be trained to recognize the difference between a cat and a dog by analyzing thousands of images of cats and dogs. When it comes to recognizing and classifying objects, AI systems are generally more accurate and consistent than the human brain. They can recognize objects in a fraction of a second and with much higher accuracy than a human. However, the brain has several advantages over AI when it comes to vision. For example, the brain can recognize objects in a wide range of lighting conditions and perspectives, whereas AI systems may struggle when presented with images that are outside of their training data. Additionally, the brain is able to interpret depth and distance in ways that are still not fully understood by AI systems. Overall, while AI may be the winner when it comes to recognizing and classifying objects, the human brain is still the superior system when it comes to vision as a whole, due to its flexibility, adaptability, and ability to make sense of visual information in a more holistic and nuanced way. This round goes to the brain. Number 2, learning. The human brain has an amazing ability to learn and adapt to new information through a process called neuroplasticity. Neuroplasticity refers to the brain's ability to form and reorganize neural connections in response to new information, experiences, and environmental changes. This ability allows us to learn new skills, acquire new knowledge, and adapt to changing circumstances throughout our lives. AI systems also have the ability to learn and adapt to new information through a process called machine learning. Machine learning algorithms allow AI systems to analyze large amounts of data, identify patterns and relationships, and make predictions and decisions based on that data. As AI systems process more data, their performance improves, and they become better at recognizing patterns and making predictions. Recently, we've seen the explosion of ChatGPT, an AI chat application that was trained on more than 570 gigabytes of text data. Which might not sound like much, but remember, this is not 570 gigabytes media file, 570 gigs of pure text, which is a massive amount of text. Machine learning is also used to recognize images, like we mentioned earlier, and even sounds. Overall, the winner in the area of learning and adaptation is a tie. While the human brain has an amazing ability to learn and adapt through neuroplasticity, AI systems are also capable of learning and adapting through machine learning algorithms. Both the brain and AI systems have unique strengths when it comes to learning and adaptation, and both are essential to our ability to acquire new knowledge and adapt to changing circumstances. Before we get to number 3, please subscribe so that our brain can continue creating content for your brain. Okay, number 3, creativity. The human brain's ability to create and imagine is still not fully understood. However, it's clear that creativity is a combination of various parts of the brain working together in a unique way. The frontal lobe, which is responsible for decision-making and problem-solving, plays a critical role in the creative process. The temporal lobe, which is involved in processing sensory input, also contributes to creativity, especially in areas such as music and art. The brain's creative process involves making connections between seemingly disparate ideas and concepts and generating new insights and perspectives. It relies on past experiences, emotions, and imagination to generate new ideas, and it's highly adaptable to new and unfamiliar situations. AI systems, on the other hand, rely on algorithms and data inputs to generate new and creative outputs. These algorithms may use techniques such as generative adversarial networks, GANs, or reinforcement learning to create new and unique outputs. For example, an AI system may be trained on a dataset of paintings and use this information to generate new pieces of art that mimic the style of the original paintings. While AI systems can generate impressive and original outputs, they are still limited by the algorithms and data inputs that they are trained on. They are not capable of making the same kind of imaginative leaps and connections that the human brain is capable of. Additionally, AI-generated outputs may lack the emotional depth and context that comes from the human experience, making them less relatable or impactful. Overall, while AI may be able to generate novel and interesting outputs at unmatched speeds, this round goes to the human brain due to its adaptability, emotional depth, and ability to make connections between seemingly unrelated concepts. Number 4, motor skills. The brain controls movement through a complex system of neural signals. The motor cortex, located in the frontal lobe of the brain, is responsible for planning, executing, and coordinating movements. This region of the brain sends signals to the muscles through the spinal cord and controls movement and posture. The brain's control of movement is incredibly complex and precise. It allows us to perform fine motor skills such as writing, playing an instrument, and using tools, as well as gross motor skills such as running, jumping, and dancing. Additionally, the brain's motor control system has the ability to adapt and improve through practice and repetition, allowing us to learn new skills and improve our existing ones. AI systems, on the other hand, can be programmed to control robots and other machines. These systems can execute precise movements with speed and accuracy. However, they do not have the same level of adaptability and creativity as the human brain. While AI systems can perform repetitive tasks with great precision, they may struggle to handle unexpected or novel situations that require quick thinking and problem solving. Overall, AI systems are superior when it comes to precise and repetitive movements. However, when it comes to motor skills, this round goes to the brain. The brain's ability to control movement through a complex and adaptable system of neural signals is unmatched by current AI systems. Number 5, communication. The human brain processes and produces language through a combination of neural signals and chemical reactions. Language processing involves many regions of the brain, including the Broca's area and Wernicke's area, which are responsible for producing and understanding language, respectively. Language is a fundamental aspect of human communication, and it allows us to convey complex ideas and emotions to one another. The brain's language processing system is incredibly sophisticated and allows for a wide range of communication, including verbal and nonverbal communication. It also allows for the creation and understanding of figurative language, such as metaphors and sarcasm, which is a hallmark of human communication. AI systems, on the other hand, use natural language processing algorithms to understand and produce language. These systems can analyze vast amounts of data and understand natural language commands, making them useful for a wide range of applications, including virtual assistants, customer service, and language translation. While the human brain is still superior in its ability to process and produce language, AI systems have made significant strides in natural language processing and are becoming increasingly sophisticated in their ability to understand and produce language. And the meteoric rise of ChatGPT is a testament to this. As a result, both the brain and AI systems have their own unique strengths when it comes to communication, and both are essential to our ability to communicate effectively in today's world. For communication, this round is a tie. Number 6, memory. The human brain's memory system is highly complex and involves multiple regions of the brain working together. Memories are stored through neural connections, and the process of creating and storing memories is called encoding. Retrieval is the process of accessing stored memories and bringing them to conscious awareness. The brain has a remarkable ability to store and retrieve vast amounts of information. It does this through a process of synaptic plasticity, which means that the strength of connections between neurons can be modified based on experience and learning. Memories are not stored in a single location in the brain, but are distributed across different regions, making it more difficult to lose all memories due to damage or injury to a single part of the brain. AI systems, on the other hand, use algorithms and data storage to access information. These systems can process and store vast amounts of data at a speed and scale that is impossible for the human brain. However, AI systems do not have the same ability to process and understand the emotional or contextual aspects of memories, which is an important aspect of human memory. This round goes to AI because they are superior in terms of their ability to store and retrieve large amounts of information quickly. It's also virtually limitless as more hard drives can be added at will. Human recollection can also be flawed and change over time. Number 7, decision-making. The human brain's decision-making process is complex and involves multiple regions of the brain working together. The prefrontal cortex, which is responsible for executive functions such as planning and decision-making, plays a critical role in the process. When faced with a decision, the brain analyzes the available information, weighs the potential outcomes, and ultimately makes a choice based on a combination of logic and emotion. The brain's ability to integrate and process both rational and emotional information can lead to more nuanced and holistic decision-making. The brain also has the ability to adapt and learn from experience, which can lead to more effective decision-making over time. AI systems, on the other hand, approach decision-making through the use of algorithms and data analysis. These systems can process vast amounts of data and use machine learning techniques to make decisions based on patterns and trends in the data. For example, an AI system may be used to identify patterns in financial data and make predictions about future market trends. While AI systems can process and analyze data at a speed and scale that is impossible for the human brain, they can be limited by the quality and bias of the data that they are trained on. Additionally, they are not capable of the same kind of nuanced decision-making that comes from integrating both rational and emotional factors. Finally, AI systems may not be able to handle unexpected or novel situations as well as the human brain can. Overall, while AI may be ahead when it comes to processing and analyzing data, the human brain is still the superior system when it comes to decision-making due to its adaptability, ability to integrate both rational and emotional factors, and capability to handle novel or unexpected situations. Number 8, energy efficiency. The human brain is incredibly efficient, using only a small amount of energy, about the same as a light bulb, to perform complex tasks. The brain uses glucose and oxygen to fuel its activities, and even though it accounts for only about 2% of the body's weight, it consumes about 20% of the body's energy. Despite this, the brain is still able to perform a wide range of complex tasks, including language processing, decision-making, and motor control, while using relatively little energy. AI systems, on the other hand, require significant computing power and energy to function. AI systems use specialized hardware, such as graphics processing units, GPUs, and field programmable gate arrays, FPGAs, to perform the massive number of computations needed for tasks like image recognition, speech recognition, and natural language processing. These systems require significant amounts of energy to operate, and their energy consumption can be a significant factor in their practical applications. Overall, the overwhelming winner in the area of energy efficiency is the brain. The brain is incredibly efficient, using only a small amount of energy to perform complex tasks. AI systems, while impressive in their ability to perform complex tasks, require significant amounts of computing power and energy to function. As a result, the human brain remains the most energy-efficient computing system we know of. In the battle between the brain and AI, the winner depends on the specific area or ability being considered. While AI has made incredible advances in recent years, the brain still holds the edge. But keep in mind that every 3 months, the speed and power of artificial intelligence computation doubles. So, some areas where there are ties might shift to AI soon, since our evolution happens far, far slower. But for now, the brain remains the smartest in the camp. Thanks for watching. Remember to subscribe.